Hey guys, welcome to 6.6. I'm going to go through the bell ringer here quick. This is synthetic division, so remember to take the opposite of n, which is +2. You have 1, 0, -7, -6. Bring down your 1, multiply, you got 1 times 2 is 2, add them, 2 times 2 is 4, add them, and multiply these guys, you're going to get -12. So this is -12 over x minus 2 minus 3 plus 2x and plus x squared. There's your bell ringer, okay? So that's synthetic division. That's definitely something you would know before you would want to come into this section. So let's jump down into our actual new notes. How do we use or find rational zeros of polynomial functions? Here's your function here. You want to make a note of what P and Q is. This is your P value, this is your Q value, which is 1. There are your factors for P. Here are your factors for Q, and they give you all these combinations, okay? And then you'll guess which one works and actually test it to see which one gives you a remainder of 0. And then whatever is left, you can factor it from there. So that's what you can see they're doing here. But let's actually jump right into this, save a little time, because I only have 15 minutes to get through this, and this is a pretty long section. List all the possible rational zeros of f using the rational zero theorem. So this is your Q, this is your P. Numbers that multiply to be P are 1, 2, 3, 4 times 6, 3 times 8, 2 times 12, and 1 times 24. Q is just 1 at the bottom. What I'm going to do is I'm going to set these up as fractions. Okay, I'm going to have P over Q. I'm going to go through every combination. So I'm going to do my combinations of 1 here. 1 over 1 plus or minus and 1 over 5. Okay? In blue, I'm going to do my combinations of 2, so 2 over 1 and 2 over 5. The 3 I'll do in red, so my combinations will be 3 over 1 and 3 over 5. See a pattern forming here or a common theme. Next one is 4. 4 over 1 and 4 over 5. Okay? Going to 6. I guess I'll do pink. 6 over 1 and 6 over 5. Go to green for 8. 8 will give me 8 over 1 and 8 over 5. Alright, maroon I'll do 12. 12 over 1, 12 over 5. And lastly, in brown, I'm going to do 24, which will be 24 over 1, 4, and 24 over 5. So here are all my combinations for number 1. Good news is 2 is not as complicated. Again, P is 16, Q is 2, so when I list my factors of 16, I got 1, 2, 4, 8, and 16. Q is going to be 1 and 2. Now, when I do P over Q, I'm going to do my 1s first in purple. So this is going to be 1 over 1 and 1 over 2. It's the only one that I'm going to have to write 2 over. 2 I'm going to do 2 over 1 and 2 over 2. Well, I don't have to put 2 over 2, because 2 over 2 is 1 and I already have it. So I'm technically finished with 2 then. 4 over 1 and 4 over 2. Well, 4 over 2 is 2. 2 is already here, so I don't have to do that one twice. 8. 8 over 1 is 8, and 8 over 2 is 4. I already have 4 there, so I'm not going to write it again. And my last one is 16 over 1. 16 over 2 is 8, so I'm not going to write that. So all my combinations are there already. So that's a lot less. If they double up, you don't have to write them twice. Okay? So that's listing all your possible rational zeros. Now, in the first practice here, they don't make you list them this time. They just want you to actually test those possible roots. The roots they're giving you to test are 1, -1, 2, and -2. I'm going to write out synthetic division. What I'm going to notice here is there's a lot of negatives on the end. So it might be difficult to switch it over into a negative. So I probably will have to do a negative number. Well, let's just start a positive 2, for example. 1 times 2 is 2, you get 5, 10, 3, 6, -21, -42. That's not going to give me 2. So this is a no-go. 2 is a no-go. I'm now going to go to, say, negative 2. I'm going to do 1, 3, negative 7, 27, and negative 18. Break down 1. This is negative 2. This is negative 9. 18, which is negative 9. This is positive 18. Yes, this one works. Negative 2 is a go. Now, let's keep working. I am not going to use this original numbers again. 1, 3, negative 7, negative 27, negative 18. I am now going to use what's left. So I'm looking at 1, 1, negative 9, negative 9. I have 2 numbers to test. I'll just go to the left. Negative 1. This is negative 1, 0. Nothing 0. Negative 9, positive 9. Life is good. Once you get to this point here, where you only have 2 solutions left, I can now solve for my remaining 2 solutions by solving a quadratic. We have a quadratic formula, we can factor, we can go about this any way we want, which is why we taught you chapter 5. I'm going to do this the hard way by factoring it. So I have plus 3 minus 3, so x plus 3 equals 0, and x minus 3 equals 0. So this will be negative 3, this will be positive 3. So your 4 solutions, x can be negative 1, negative 2, negative 3, and positive 3. And that's basically how you go through this. Now this one wasn't as bad because they narrowed down our scope of how many possible rational zeros we have to pick from. We won't have that luxury in number 1 here. Okay, we're going to solve 1 and 2, and then we'll move on down to the bottom. Well, let's start with P and Q. We actually got to list what we have here. 1 goes into 72, 2 does, 3 does, 4 does, 18, 5 no, 6 times 12, 7 no, 8 yes, 8 times 9, 6 times 12, 4 times 18, what do we got next? 3 times 24, 2 times 36, and 1 times 72. Q is nice, it's only 1. If you want to list your fractions, you can. But basically your fractions are this. P over Q would be basically your P values. Anytime you divide by 1, it doesn't change anything. Just remember we need to do a positive and negative each. So let's start with, say, 4. We got 1, negative 5, negative 18, and 72. This will give me negative 1, negative 4, negative 22. That's going to be negative 88. I'm over. So 4 is not going to be something that's going to work for us. So I want to pick something that's going to basically, probably something smaller. 88 went over 72. So what's the number that's smaller than 4? We don't have to do 4 again unless we want to do negative 4. Let's do 3. Okay, so this is 1, 3, negative 2, negative 6, negative 24. 3 times negative 24. Oh, that's negative 72. So Yahtzee. That means our one answer is 3. To get our other 2, I can use quadratic formula or just factor this. If I do that, I get x and x equals 0. Got plus and minus, 6 and 4. So this one's negative 4. E is going to be positive 6. So our 3 solutions are 3, negative 4, 6. 3 answers? Yes, there are. I have all 3. All right, number 2. Here's your P, here's your Q. So P will be 1, 2, 4, 5, 8, 10, 20, and 40. Q is just 1 again. So again, I just have to worry about positive and negatives out of that group. When I list this up for synthetic, looking at this scenario, I am probably going to want to pick a positive number. When I multiply a positive times its negative, it'll be negative. I'll give me a negative number, and I'll get a negative number here. That way I'll get 0. Remember, my goal is 0. So I'm probably going to pick something like positive 4. Let's see how this does. That's negative 12, negative 10, Yahtzee. Now normally I don't guess correctly the first time, but you can make educated guesses. So 4 is go. We have x squared minus 3x minus 10 equals 0. This is x minus 5, x plus 2 equals 0. So x is 5 and x is negative 2. And that would give us our three solutions. Negative 2, 4, and 5. So there's 1 and 2. Not bad. Not too many. We didn't have to do any fractions yet, so life was good. Let's try number 3. E is 30, so 1, 2, 3, 5. 5 times 6, 3 times 10, 2 times 15, 1 times 30. Sweet, Q again is 1. We're not always going to be this nice. Eventually we'll have to do some fractions. But right now, we're okay. All right, so synthetic. 1, negative 8, negative 23, and 30. Again, probably going to want to pick a positive number here. So if I pick a positive, I'm guaranteeing that these will be different signs. It's going to have to be a small number. 23 is not that much smaller than 30. So I have to be very creative here. I'm going to try positive 2. 1 times 2 is 2, negative 6, this is negative 12. And you can see I've already gone over. Okay, so this is going to be what? Negative 35, and that would be negative 7. So 2 is not a go. I'm going to try 1 next. And if that doesn't work, I'm going to start trying negatives. Okay, so this is 1, negative 7, this makes negative 30, and yay, that worked. So this leaves me with x squared minus 7x minus 30. Your factor is going to be x minus 10 times x plus 3. Alright, and that means x is positive 10 and x is negative 3. So our three solutions are negative 3, 1, and 10. And 4. Here's my P, here's my Q. Ooh, this one's going to take a while. I have 5 solutions. So I have 1, 2, 3, 4, 6, 4 times 9, 3 times 12, 2 times 18, and 1 times 36. Q is still 1, so at least we're not getting too bad with the actual Q values. Don't forget 0 for your x here. Okay, let's look. Negative numbers are probably going to be the way we have to go. It's the only way we can get rid of these negatives to get this to be positive. So, still going to start relatively small. I'm going to go negative 2. Remember, because these are positive negative values here. 1 times that and negative 2. This is positive 2, negative 7. This is positive 14. This is 9, negative 18. Oh. Money. Educated guesses do work. Okay, so negative 2 is a go. Keep that. Now, remember, we're going to use the points that are here. These 4 numbers, 5 numbers, I'm going to use. Now, the next number I'm going to test, let's look at what we have. We have a negative, positive to a negative to a positive to a negative. So I probably want to test positive numbers here. Okay, just what positive number are we going to test? No, I'm actually going to go negative. Start small, negative 1. I want to see what happens. This is negative 1, negative 2, positive 2, negative 5. This is positive 5, which is 14, which is negative 14. No dice. So negative 1 is not going to be something I'm going to look at. So I'm going to jump back here. What should we try next? Negative 1 is off the map. What happens if I use positive? Nope, not going to give me positive 18. So 1's completely off the charts. I can get rid of that 1 altogether now. So up here on my list, E is definitely off the map. How about positive 2? That would be 1, that would be 2, negative 5, negative 10, negative 1, negative 2. So that's not looking good either. So 2 is off the map. I guess we're at 3. Work my way up. So 1 times 3 is 3, 2, 6, negative 1, negative 3, 6. And look at that. 3 is the one that we want. Now, I still have 3 answers left, so I can't yet factor this guy, so I have to keep going. Again, I already tested through 1, 2, 3. I can test negative 3. Okay? So 1 times negative 3 is this. That's going to be positive 3, which is 2.